Hi, in today's electric motor repair tip, we're going to demonstrate the right way to use an induction bearing heater to install an interference fit ball bearing on a machine shaft. In this case, we'll be mounting a 6312 ball bearing on the shaft of this horizontal induction motor. The video is going to cover work area cleanliness, shaft inspection and preparing the shaft, pre-assembly tips for handling the bearings, how to use an induction bearing heater to expand the bearing for mounting, how to monitor the bearing temperature, and how to install a heated bearing safely. Most bearing manufacturers say it's acceptable to mount small bearings up to about an 09 basic bearing number by pressing or driving the bearing onto the shaft. But for larger sizes, the recommendation is to heat the bearing to temporarily expand the inner race. That way the bearing will slide easily into place with no risk of damaging the bearing. Induction bearing heaters produce an AC magnetic field that generates eddy currents in the bearing to heat and expand the bearing. Most of these are flat plate or bore bar designs that come in various sizes and configurations, and they're just suitable for different application requirements. We'll be using a bore bar bearing induction heater because that's the type most commonly used in service shops. Other ways to heat bearings may pose safety hazards as well as risk of contaminating or even damaging the bearing if they have uncontrolled heating. These would include oil bath heaters and open flame, and I'll just reiterate that open flame is an absolute no-no for heating and expanding a bearing. Besides an induction bearing heater, we'll need heat resistance gloves, some crocus cloth, a wire brush, and clean lint-free cloths. As always, follow your company's safety practices, wear the proper personal protective equipment, in particular safety glasses. Before starting, we're going to make sure all the parts that need to be assembled behind the bearing are in place. In particular, in this case, the bearing cap, but shims, any kind of rotating or stationary parts that won't fit over the OD of the bearing. We'll also make sure the work area is clean, free of any kind of dirt and contamination that might contaminate the bearing or the lubricant. So to protect the bearing from airborne debris, leave it in its original packaging until we're ready to actually install the bearing. After that, keep it covered anytime it's not being handled and when you don't need it to be uncovered. By placing our induction bearing heater close to the work area, we'll minimize the transition time to move that hot bearing from the bearing heater to the shaft and not have too much cooling. We also reduce exposure to any airborne contamination that might damage the bearing. Before mounting any bearing, we want to make sure the journal surface where we're going to install the bearing is clean, free of any sort of debris or contamination. And usually crocus cloth, a clean cotton rag, or a wire brush is adequate to clean that surface. So we want to be sure that we carefully inspect the bearing shoulder here, because if the bearing seats up against a burr, it's going to cock or tilt the bearing and we won't have a reduced bearing life. So we really want to make sure that shoulder is square and free of any kind of dings. When we're using an induction bearing heater, pick a size and a setting that won't raise the bearing temperature too quickly. The inner race warms up a little bit faster than the outer race. If we heated it too quickly, it's potential that we might close up the internal clearance and cause Brinelling damage to the bearing. By heating the bearing to 100 degrees C, which is about 212 F, that will accommodate the internal clearance of most standard bearing fits. So to avoid damage from loss of internal clearance between the balls and the races, never heat a bearing to more than 105 degrees C, which is about 220 F. The induction heater that we're using does not have a thermal sensor, although some do. In this case, we'll be using an instrument with a temperature probe in order to monitor the temperature of the inner race. So that's our thermocouple and instrument here. We could also use a temperature stick, and you want to use one that's a 210 Fahrenheit temperature stick so that you can tell when the inner race is at temperature. Although the infrared non-contact thermometers are popular, The problem with using those for this task is that the shiny bearing surface results in a very low emissivity, so we may get a less accurate reading. So for that reason, we're using a contact type thermocouple. For standard bearing fits, we're going to heat the inner race to 100 degrees C, which is 212F, and that will expand the bore enough to slide the bearing easily onto the shaft. We never want to exceed 105 degrees C, which is 220F. Wearing heat-resistant gloves will gently start the heated bearing onto the shaft, and being careful not to get it stuck partway on. So you just want to slide it quickly into place. Make sure it slides easily before you push it all the way against the shaft shoulder, and then hold the bearing firmly against the shoulder for a few seconds to make sure it's in place. Or you can use a soft device such as a brass drift punch here or a bearing knocker to lightly tap the inner race to make sure it's firmly seated against the shoulder. For those rare designs that have a lock nut retainer, wait until the bearing is completely cooled to room temperature before you fully tighten the nut. Otherwise, the contraction of the inner race will result in that nut not holding the bearing firmly clamped in place. The outer race will remain warm quite a bit longer and shrink more slowly than the inner race. So we don't want to get in a hurry trying to put the end bracket in place. So wait till the bearing is completely cooled to room temperature before you pack it with grease and install the end bracket. So to protect the bearing from airborne contaminants as it cools and prior to reassembly, we're going to either cover it or wrap it with foil. Never use plastic. Plastic can melt and stick to the bearing, and then you'll have a real mess. Installing an interference fit bearing onto a shaft is not difficult. It just requires a little planning, the proper tools, and attention to cleanliness to make sure we have optimum bearing life. Thanks for watching. Join us again soon for more ESA electric motor repair tips.